Yes, sir. Start, sir, please.
Yes, very good morning to one and all present here. Myself, Irfan from ICT Academy, and I'm a relationship manager of ICT Academy Pune region. And we feel privileged to conduct this virtual seminar in association with Tuljaram Chaturchand College of Baramati, Arts and Science, on data science and its application. And I welcome the faculties, HODs, and our beloved principal of institution and beloved students to the seminar. And I also welcome our eminent speaker, Mr. Sarath Babu sir, is a director, product and development Oracle, and Mr. Dilip Muralidharan sir, senior technical instructor, Splunk. And let me call upon our first speaker, Mr. Sarath Babu sir, director, product and development. And I'll quickly go through his profile. Like Sarath Babu sir has started his career in Wipro Technologies as a project manager. And then he moved to the Birla Soft as a program manager, and now he is being associated with Oracle India Private Limited as a director product development. He completed his master in Indira Gandhi National Open University. He mentored government school students for NMMS scholarship examination. He conducted various seminars, guest lecture in and around 60 plus odd engineering colleges so far. His area of expertise are machine learning, Hadoop, blockchain, certification, Visual, C++, Java, J2E. So let me hear a few words from Sarath Babu sir. Over to you, sir.
Thank you, Irfan. So I think just a small correction on my introduction. So I did my master's in computers from...
Sorry to disturb you.
Yes, sir. Yes, sir. Sorry.
Our principal sir wants to speak few words.
Yeah, sure.
Yes, sir. Sorry, sir. Yes, sir.
Principal sir, please proceed.
Good morning, everyone. It's my pleasure that ICT Academy has given us a positive hand to organize this visual power seminar, a very important and vital topic of today's world. On behalf of TC College Baramati, which is an autonomous institute of higher education, working for last almost 60 years, the resource personalities who are supposed to enchant the people and participants who are joining today, Honorable Sharad Honorable Deepak and G. Venkatesh, who are really spellbound experts in their fields. I welcome on the behalf of TC College Baramati. I expect that data science and its applications, it is having the virtue not only in the field of computer sciences, but almost it has touched each and every horizon of every discipline and every commodity. As far as today's post-COVID era is concerned, I'm much more aware that the situation is much more grave, almost on each and every front. I'm talking about the two important fronts. The first front itself is the education, which is going to provide the professionals for the future. And the second front is obviously the healthcare. I do feel that the implications which will be relating in today's seminar, they will be helping almost all of the participants and also the dear fellows who are associated with this webinar, so that they can give some boost, they can get some roadmap, so that they can carve out more professionally in coming days. I again welcome Honorable Sarath who is supposed to be the first resource person, and Dilip ji, who has joined, and G. Venkatesh. I also thank the Honorable Muhammad Irfan, who is the relations officer, who has taken pains to make this event possible. Wish you all the best. Have a great day. I take leave. Thank you.
Thank you so much, sir.
Thank you. Yeah, please.
Thank you, sir. Thank you for the warmth and kind introduction. That really means a lot to us. And thanks to the college management for trusting me on this and doing this session. And at the same time, thanks to ICT Academy as well for the opportunity. So I have a long association with them. I was doing a lot of sessions for other colleges as well. So without any further ado, I know like we have an hour and a half to go over this. In that, I'll probably take 45 minutes, and then my fellow speaker will cover the rest of the time. So I'll just talk a brief about me. So I did my master's in computers. As Irfan mentioned, I started my career with Wipro. I was there for about 10 years, and I was in US for about 3 years. I did work with most of the multinational companies, including General Motors, General Electric, Nokia, and Swiss Bank. So I have varied experience in terms of manufacturing, banking, and currently I'm leading a product suite in the insurance domain. I'll be leading. I was leading all the engineering team, which includes development, infrastructure, QA, and all that. So this is a brief about me, and interacting with students and talking to them is my passion, which I started doing this for the last few years. And so I think today's topic is really very relevant. I really appreciate the college management to pick such a relevant topic, which is definitely important for all the students to know a little more. And I assume like students might be already knowing a bit about this. They might have read a lot of articles and all that. But I just want to put my perspective on this particular topic and what's going on, and what are all the opportunities we have, and how is that we can probably grab those opportunities. So these are some of the things I would like to touch upon. Okay, so with that, let me start presenting my slide deck. 1 second. You just need to tell me, okay, it is not allowing me to present. 1 second. So you're seeing my screen, right? Can you guys confirm me? Fawn or somebody, can you guys?
Yes, sir, we can.
Okay, great. So before even I jump onto what is data science, I think you all might have been read about data, right? Because we talk a lot about data these days. And we all would have studied in our database course the difference between data and information, right? So data is something which is abundant, which is raw, and but it by itself cannot tell you what we need to do with the data, right? So that is where we will try to process the data and derive at some information, and that information will be our source to make decisions. So this was not just something which we started today, right? It was there from long time. But why is it that it has so much buzz today? And why we are talking a lot, at least in the last 4 years, 3-4 years, I think this has become like very much visible. Everybody, if you take any industry meetings or industry discussions or academics, research, wherever you go and see, I think you're seeing a lot of buzz about this data science. So I was also thinking like you, why is it so? What's happening exactly? Because in theory, I think we can read a lot in our curriculum, in our books, in our magazines. But until and unless we get onto the ground and see what is going on surrounding us, then we will not be able to appreciate the kind of attention it is getting, right? So similarly, I was also trying to look around and see why so much buzz and all that. So recently, I was in that process. I was talking to one of my neighbor. He basically works in a startup company. So I was just curious. Typically, the startup companies comes with some crazy ideas, and they'll definitely try something new, innovate, and do something good for the industry and all that. So I was a little curious on knowing what exactly this guy is doing. So I asked him, "Hey man, what's that you are doing? What's that you're working on?" So then he immediately told that, "Sharatha, I'm working on machine learning." So then I became a little more curious. Okay, so what in machine learning? What exactly is your domain? So then he told, we are trying to address some problems in the airlines or with airports. So then that made me a little more curious, and I asked, okay, can you please elaborate? So then he told me so typically in the airport, the time the flight lands and again the time the flight take off, right? There is a turnaround time. So the turnaround time is basically what happens is when you land, when the flight gets landed, so a lot of communication happens, because the thing is, the people has to communicate to the to people to put the bridge to get the people transported, and also they need to get the baggage transported to the conveyor belts, and at the same time they need to also get the onboarding people's luggage. They need to get the onboarding passengers, and again the flight has to take off. So all this process is very a lot of coordination and collaboration is required. So in the sense they typically use all these walkie-talkies and they talk, right? And the key thing here is, if any flight gets delayed by some time, right? Then what happens is it costs them huge money. And in fact, I think when they did this research, they realized that it turns into millions of dollars, right? So that the timing and that accuracy is very, very, very important. So what they were thinking, so how we can probably make sure that this turnaround time is always intact, we can improvise, optimize. So that is when what they did was, I think you might have read about IoT, right? Internet of Things. So they put a lot of sensors around the airport and all that. And there are so many small applications sitting, and they're reading these sensors, and they're really telling the things, giving the message that, okay, the flight has come and this thing has gone. So the thing is, whatever the overheads or whatever the bottlenecks they see with manual communication, so they already got streamlined. Because sometimes what happens is, if some person's walkie-talkie is not working, if the communication is not clear, that will delay the process. So similarly, if some person is not active or not vigilant, then he may miss on communicating some things. So there are always a possibility of human errors in these kind of sensitive and time-bound activities, right? So with this setting up these sensors and collecting this data and making sure that these communications are happening seamless, and also the other important thing is, one thing is operationally they have improvised. The other thing is they were able to gather a lot of data. So this data is helping them to derive insights on where exactly they are lagging, where exactly there is a scope to better it more. So that is the way they are continuously improvising. So that is what is their application they are working on. And the other interesting thing which I realized was, they have a sensor which can detect the flight which is at around 200 nautical miles from the airport. So that means all these ground duty people will start their activities knowing that, okay, the flight is going to come in the next 15 minutes. So the people will come, the buses will come, all these things will happen. So all these things have optimized the process, right? So the thing is, one is definitely the data plays a vital role in optimizing the things. And also, data also helps in deriving insights such that you can continuously work on improving things one after another. So that is one example which has really made me think, oh, okay, so the data science is something we need to be worried about. We need to understand a little more. So that is when I started thinking about it a little more, little broad and all that, right? So with that, let me quickly jump onto some more real world scenarios. You might have seen these, all these players, no? Walmart, Netflix, Rolls-Royce, Shell. Again, what is the common point for all these things? Means, for all of them, they are big, they are masters in their respective fields, and they are doing a lot of things, right? So for example, if you take Walmart, as you know, Walmart is a big supermarket which has big stores cut across countries, geographies. Especially they are more focused in US, but they have presence everywhere. And the thing is, they always go with technology a lot, right? In the sense like, especially, they need to, so when for these supermarkets, the important thing is their inventory management. Because inventory
Sharon,
management,
sir, sorry to disturb you.
yeah,
Sir, please go to the, please start your screen. That means slideshow mode.
okay, sure, I'll do that.
Okay, that's it. Sir. Thank you very much, sir. Please go
No
ahead.
problem. Sorry, and thanks for reminding me. Sorry, I missed that. So okay, so Walmart is more of weather-sensitive products, right? So whenever there is, sorry, Walmart is a big one, but weather-sensitive products is something which is part of it, right? So what is the challenge there? Means, see, in any supermarket, the important thing is the inventory. So it's about chicken and egg kind of problem. So the thing is, if you stock up too much, and if the consumption is not there, you are incurring the cost for storing, right? So you're not leaving room for other important items and all that. And suppose if you get very limited stock, then you may be missing on the consumers, because people may come and go, and also that's a bad customer experience, and they think that, okay, Walmart is not providing this. So what they thought was, especially they try to look at these weather sensitive products. Weather sensitive, what I mean is, say for example, whenever there is a storm, whenever there is something wrong, we try to pile up certain things. For example, now in the COVID situation, what we are doing, typically I can tell myself, I'll try to pile up on the vegetables. So I try to minimize my going out. So I'll try to say that, okay, I need to probably bring vegetables at least for a week. So something like that. So that is one thing which they want to balance it out, such that they should not have overstock, or they should not have what you call understock, right? So that is one thing which they want to predict with the data and all that. So how this data helps here is, when you have the history of all the data, you will get to know the buying patterns of the consumers. When you know the buying patterns of the consumers, then what is that you can do? You'll be able to, okay, based on the trends, you'll be able to predict. So, okay, I think based on whatever the history I have, I can say that probably this time it's going to need this much of stock. So the predictability can be possible only if you have that history of data, and if you can put some statistical algorithms and modeling, then you'll be able to predict that what is it you need. Similarly, Netflix, if you see how Netflix is working on, I think now today with cinema halls down and all that, I think we are relying a lot on Netflix. And Netflix uses data a lot. How? Because it has a lot of recommendation systems. So the thing is, I think you might have already observed these things, right? So based on your viewing pattern, it can understand your taste. It can understand the genre of movies you like, right? And then it will recommend you that, okay, next time when you open a Netflix, it will show you the other movies or series which probably align with your taste. So how all that is possible means, again, data. So it is having a data of your view, right? So for the past months or years, so based on that, it keeps on churning that, and it's going to keep on recommending you the relevant things. So if you're watching a lot of history kind of serials, then it can recommend you something in those lines. So that is another use case. So similarly, if you see Rolls-Royce is, they'll make jet engines and all that. So again, so if you know, right, typically a flight has so many sensors within itself. And the thing is, like, with so much of data on board, it will have a lot of opportunity to take right decisions and all that. So that is basically and for doing that, for a situation like jet engines and all that, the data is very important, because some of these things you cannot test on live, right? You have to test in a simulated environment. So when you are testing in a simulated environment, what happens is you need data, because you know, right, for a flight kind of scenario, there is no scope for error, because a lot of lives will be at stake. So that means your prediction, your accuracy of the prediction should be 100%. There is no go. At least no 99.9999%, it has to be. So So that means here also data plays a role. So how much ever data you include in your simulations, that much of accuracy you can see in your predictions, and that is the way you can plan your, you can probably model your engines to cater to the needs, right? Shell is known for oil exploration, and you know what? Shell actually invests a lot on these particular projects, and sometimes what happens is they typically go into oceans. They try to dig onto the oceans deep. Sometimes they may invest a lot, but they didn't find any oil. So the thing is, so this is one very capital intensive activity, right? Because drilling in an ocean with so much of equipment, machinery is not simple, and that is a very cost associated activity. So what is that we need to do is, this data can help them based on the history, based on what they have done so far. They can always tell them that based on the nature of the rocks or the soil, whatever is underneath, or based on so many other parameters, it can easily sense and tell that, okay, this is the area where you can go and drill such that you can see the oil. So I'm just giving a high level perception to you guys that picking these various domains. I have some more real world things which we can talk about. But before jumping on to the data science concepts, I want you to understand the importance of it. So it cuts across all the domains, and it is very, very vital and important today. Okay, so with that, I'll take a pass. Any questions so far? Okay.
Hello, sir.
Yeah.
Hello, sir. Can you tell me the application of the same facility in terms of shipping logistics? I think you have already told about regarding the airlines. So what about the shipping logistics?
Yeah, so I think the same logic applies there too. So because when you say logistics, right, logistics is also involves so many players there, right? So we need to remember one thing. Whenever there are so many players, so all those players together will be what? That is our value chain, correct? So, and when you have such a big volume chain with so many people involved, what happens is the data plays a vital role, because any delay in any of these levels or layers will have a cascading impact on the overall turnaround time or overall this one, right? So logistics, not only logistics, anything relating to shipping, even whatever you are seeing today, right? Your careers and all these people, for them, this all will be very, very useful, because they need to cut their SLAs, because certain deliveries are very, very time sensitive, and you need to deliver on time. Otherwise, it will not make sense. So what I want to emphasize here is, any industry, data is going to be vital, whether it is logistics, whether it is airlines, whether it is retail, and even I'll touch on some of the other things like agriculture, construction, and other industries. But yes, so that is what it is. So I think only thing is, we need to look at each and every player in the value chain. So where exactly that shipping is getting started. So what are the intermediate stages where it is going to, from that stages to the final destination. So all this entire chain we need to look at, and we need to understand the data from all these dimensions, and then we need to see how we can probably improvise. So does that answer your question? Sorry.
Yes, sir. Thank you.
Yeah, sure. So this is just a quick thing. I think I don't need to probably talk about it. This is self-explanatory. And this is the data from 2019. What happens in 1 minute, right? So we're all on social media. We're all on WhatsApp, whatever, right? Facebook and so many other social media. And so if you see here, this is the kind of data we are living in today. So when you have so much of data, and if you cannot create insights from it, or if you cannot tell a story from it, I think what is the use of it? So we need to use that, right? So that is what is the motivation or inspiration for all of us. And so what else is the motivation means? The other important thing is, computing was more or less limited so far, but the computing power has increased now, right? In the sense, we are talking about high performance computing. So the processing power has increased multifold. You all might have read about Moore's law, right? It is getting doubled, and slowly it reduced. So now slowly people are talking about that in the next few years, or already it started actually, that Moore's law is going to be saturated. So now we are looking at quantum computing and all that. So there is a lot of developments in the processing, because of which you can process things very fastly, right? And the other important thing is storage. You also have a lot of options to store. Your storage has become cheap, very much affordable. Because when I started, right, my career 22 years back, we used to have a small floppy disk, and we used to store very limited information. And compared to that, and today, we talk about block storage, we talk about whatnot. We have all kinds of things. We can store data in the form of petabytes. You know what? How many petabytes the Zoom is generating every day because of their video streaming? 7 petabytes. 7 petabytes of data is getting generated every day by Zoom. That means, you just imagine 1 petabyte means what? It is in 1000 terabytes. And again, that means it is 10 to the power of 15. So I think you just imagine the kind of data we are generating. I'm just giving one example of Zoom, but you can imagine the kind of data floating in and out and all that, right? It all can be humongous. And so then people started thinking about, now you have all this data. First thing is how to process this data. Second thing is how to derive insights from this. And the third thing is how we can make better decisions and all that, correct? So for all these problems, we have technologies. Like, for example, for you to process this huge data, there is something called big data. So big data is basically, it is not a solution. Big data is a problem. So how to solve it? How to process? See, the thing is, you may be able to store this much of data, but my processor is still limited. It can only process to some extent. So how is that I can do? So that is what is your big data, right? So big data has come up with some methods and technologies. So that's not part of the scope of this session, but I can just give you an idea. It is more of divide and conquer. So I think we'll try to slice the processing, slice the storage, and we'll try to again process it in pieces and then collect the results, right? So I think in a nutshell, that's the way it is. And so once we have this big data processed, then what else we need to do? We need to derive some insights from this. So how to do that? So there is something called artificial intelligence, machine learning, some statistical modeling. So these are all going to help you in terms of deriving inserts. It can tell you, it can predict, right? So all these things are basically the output from this huge amount of data. So this is about the kind of data we are dealing with today. Coming to data science. So you may be wondering, what exactly is data science? So I think we all know computer science, right? Computer science is what we all want computers, machines to do things the way we do, be it a payroll processing or be it a, anything, right? Suppose if I want to key in all your students' marks, and if I want to just give me the grading and probably the segregation into groups, first class, distinction, or whatever. So all that I can program once and I can use any number of times and keep on improving it, right? So computer science, you all know. So it's more of problem solving, how we can make computer do things, whatever is going on today in the manual mode. And mathematics and statistics is something you all know. So mathematics and statistics helps you in the modeling. So in the sense, like, if you can give a set of data and if you wanted to tell that, okay, what's going to be this? Say, for example, imagine this way. So you have a table, okay? In the table, you have only 2 columns, okay? So in the 2 columns, X and Y. So what I'll say, X is 1, Y is 1. And I'll say X is 2, Y is 4. X is 3, Y is 9. X is 4, Y is 16. Then when I say x is 5, what will you say? Y is 25. How are you telling that? So your mind is already created some model that y is equal to x square, right? So that is your modeling. I just gave a simple example. But if the data is more complex, then deriving the relationship between x and y will be complex, right? So it can be a simple equation, it can be a linear equation, it can be a polynomial equation, whatever. It can be a quadratic equation, but the challenge is how to establish that data. From the data, how I can establish the relationship between x and y is the key thing here. When you can do that, then the important thing is picking the right statistical model, and then you can say that, okay, this is my model now, or this is my equation. Then you test that model, right? So how you can test the model is, again, you use the existing data to test your model. And once the model is coming out correct, then if it is having, so you can define your threshold on the accuracy. It need not be always 100% accuracy. But your equations gives you, say, your organization is okay, tolerable to 90% of accuracy. Then you can say that, okay, this is 90% of accuracy is okay. Then you can always define that, yes, I can probably start here, and I can just predict I can use this model, and you can start predicting things. So that is your statistical modeling. And business or domain. Business or domain is also an important thing, because if you want to really predict for a bank, you need to have that knowledge on what is that, the banking terminology, how the bank functions, what are all the various players, how the data flows from each stakeholder. All those details you need to know. So for data science, the important things are definitely the mathematics, computer science, and the business domain. So I'll take this a little more. So if you typically see, don't worry about this left side diagram. If you see the right side diagram, your computer science and your business. So today when you are developing an application, means for a bank, you need to have that knowledge on bank, and also you need to have some programming knowledge. That is what is your typical software development you are doing. But if you see from here to data science, so as I mentioned, there are 3 things here. So, and again, you have 3 areas. So if you're good in computer science and if you're good in your statistics, you can focus on your machine learning as the skill. That's an important thing which you can focus on. Similarly, anyhow, you know about software development. And suppose if you're good in mathematics, modeling, and if you're also good in business, you can also do a lot of research. Because if you take a bank, how I can come out with new banking products. If you are an insurance company, how I can come out with a new plans or new products. So that is what is so you can become a good business analyst, or you can become a good product manager, or whatever, right? So this is what is your typical circle. So the data science is more of an integral part of all these 3 areas. That's what is an important thing I want you guys to remember. So so this is just a definition from Wikipedia. So data science is an interdisciplinary field. That is the reason it has so many disciplines, methods, processes, algorithms, and systems to extract knowledge and insights from many structural and unstructured data. So data can be structured or unstructured. You know structured and unstructured, right? Structured data is something which is like very, very easy to visualize. For example, if you take a database table, and if you take, for example, an employee table, I can easily understand, okay, employee ID, employee name, his grade, his salary, and all that. It's very structured. Similarly, if you take student data, I can take student enrollment number, student name, his marks, his grade, and his whatever rank. So if you put that way, it is very easy to visualize. But unstructured data is, you may be looking at a feed from a Twitter, or you may be looking for a feedback from a Facebook, or you look for a video, you look at an image. So today we are talking about reading images, and you are also talking about how we can make, say for example, today, there are multiple ways people are hacking things. So I think the best thing is, like, we are looking at biometrics. We are saying that, okay, let's put biometric. And also some people are looking at how we can make facial recognition such that now, if you just look at your phones, it should be able to unlock it by recognizing your face. So all those things are going to be data driven, because for a device to recognize your face, it has to churn a lot of data because your face is an image, and that image has millions of pixels, right? So it has to collate all that. It has to identify and say, yes, you are the person you are looking at, and then it should unlock the device. So that is your unstructured data, images, your voice, your videos. All this is what is your unstructured data, and your logs. Sometimes when people have a lot of business data, your log files will tell a lot of things. So that is also something you can churn into, right? So data science is related to how you can mine all this data, how to learn about it, how to play around with this big data, and then get onto the insights such that the insights can be helpful for you to take the effective decisions, right? So that is what is the intent or meaning of this. So I'll take a pause here. Any questions so far? Okay, so I'll be moving on. Okay, so I think I have very limited time. I have another 15 minutes to go. So I'm just skimming some of the contents. I just want to focus on the important stuff. So if you look at this one, so if you see, this is a typical process, right? So as I was telling, the important thing is, so your globe talks about, the globe has infinite amount of data getting generated. So for a minute, if you're seeing so much of data generated, just imagine how much data we are accumulating, right? So you have a lot of data. So what is that you need to do? You need to process that data. So data processing is also not a small area, right? You need to think about data processing as, because sometimes data may be very raw. Sometimes the data has a lot of noise. That means a lot of unwanted things will be there. So you should be smart enough to avoid that unwanted data, avoid that noise. And also you should be able to fill the data in the sense like, sometimes there may be a lot of missing data also. So there are multiple techniques, because when you really get onto the details on data cleansing and all that, you have multiple techniques. Sometimes you can take, for example, in a database table, say that for one of the columns, some of the data is missing. So what you can do is either you can keep it as null, or either you can keep it as an average, or you can take cleansing itself. That itself is a big process. That itself can be one session which we can talk about. Similarly, for models and algorithms, I have actually put machine learning as one of the thing, but I don't know how much I'll be able to cover. But if you take machine learning and if you take all the models involved there, that itself can be one separate session. So, but in a nutshell, in a high level, this is what is the typical process. So data science, in a nutshell, I think if you can look at it, is people typically use this word called awesome. Awesome, just combining the letters from these words, obtain, you getting the data, scrubbing, massaging the data, explore, so analyze, then fit it into a model, then start interpreting, and then deriving the insight. So this is at a high level how you can think about data science, okay? And how data science is different from business intelligence. So this is also sometimes people will talk a lot about, okay, data science, but people also talk a lot about business intelligence. How do you think we can differentiate? Means, see, typically business intelligence is more, I can say more static in nature, in the sense, suppose you have a lot of historical data, and if you want to derive some things, so that is more about business intelligence. So data science is more volatile, more dynamic. It can also work in the real time, and you can see, because today we have a lot of options to pull the data, real time data, and all that. So it is more dynamic. It deals with lots of data. So that's the key difference, I can say, from data science versus business intelligence. And also typically we also talk a lot about these other things, right? We talk a lot about artificial intelligence, machine learning, deep learning, how data science. So data science touches all these things, because all these streams require data. That's the fuel for all these areas, right? So I think artificial intelligence, as you know, is not new. It was there 30 years back as well. But only thing is, it got matured over a period of time because of the advancements in the processing capabilities, storage capabilities, and all that, right? So then what is machine learning is? Machine learning is again a subset of it, I can say, because machine learning more deals with the, what you call your data part, in the sense like when you have a huge set of data, how I can learn from the data, right? So in the machine learning also, you have some categories. So I though I may not go into the details, but I'll just give you a rough idea about 3 categories what we typically see: the supervised learning, unsupervised learning, and reinforcement learning. So supervised learning is something where you will be having some data already, and you will also have what the data. So data will convey something to you. That this is, say for example, if I say 50, it will say 50 is marks. So I'm labeling that data with something. And if I say 20, okay, I'll say this 20 is age. So that way, when you give the data and what it is, then that is what is the input provided. So you have some training data which is labeled that can be useful for you to really predict. If I say, because if I say that, okay, the data, the marks are between say 100 and the age is, say for example, the people who are writing an examination of 10th, their age is probably 1 to 16, means you can easily say that the what is marks and what is age, right? So when you have the data, when I say, typically if you want to say that in that age group, say for example, 14 to 16 years, suppose if I put some, what do you call, an entrance test or some small logical test. Suppose I want to predict the IQ of some people, right? And I took, say, the age group of, probably till 2025, okay? So then I have data points saying that with the age 15, the IQ is so and so. So I have all the data. So now I want to say a new data point saying that for an age, say, 16 and a half years. So what is my IQ? So with the given data, I should be able to tell what is the kind of IQ. So what I should be able to predict. So that is your supervised learning, where you already have the data points through which you'll be able to predict. And unsupervised data is something where you will not have any such clue. So you'll be given a set of data, but you don't know whether it is an age, whether it is marks. So you don't have any clue. But the thing is, you try to cluster the data based on. So you can you know that through some algorithm or through some logic, you can say that, okay, probably the age group is, so I can probably all these age group of probably say 1 to something, I can probably group it into 1. And suppose if the IQs are in the range of say 60 or 60 to 70 or whatever number, right? So you can just group all that together. So you are kind of creating cluster based on the nature of the data. That was not explicitly told to you. So that is what is your unsupervised learning. So there is a third category called reinforcement learning, which is more about learning from our, our experience. So if you do something, if you get appreciation, we think that this is right. I think I should continue to do. And similarly, if you do something, if you're not getting the appreciation, but if you're getting some suggestions to change and correct, so you understand that this is something I need to do it differently or try it differently. So you are learning based on your experience, whether it is good or bad. That is your reinforcement learning, right? So I'm not getting into the details, but this is in a nutshell, these are the 3 categories of ML. And deep learning is going a little more and into the details, and we trying to mimic typically how our brain functions, right? So because our brain, I think we can really do lots of things with the speeds are amazing, right? So we can parallelly see them. Suppose if you are seeing this video screen, is there are so many things going on in your brain to show you that image, which we cannot consciously think about, right? So just to mimic the kind of effort the brain is putting in doing all these things, that's the reason people call it as neural network. So the neural network is also having some this thing. So deep learning is taking this neural network to next level, right? That is what is your deep learning. So I think all these are individual topics to have in a session. So I'm not getting into the details. but I just want to give you the taste of it. So I think I'm getting closer on. I'll probably need another 5-10 minutes, Irfan. So hope that is fine, right?
Yes, sure, sir. Yes, sir. Yes, sir. Not an issue.
Okay. Yeah. So with that, so I think the 3 important skills which you need for data science is your curiosity, because the data can tell you so much. But if you don't have that curiosity on what it is telling, then you'll not be able to make out from that. So I think my always request is look at the data, try to understand, try to be curious on that, try to put questions on that, and probe more on the related data. And common sense. Common sense is basically required to create patterns within the data, right? That is an important thing. And once you have that curiosity, once you research and gather a lot of details, and your common sense is helping you to put all the patterns, analysis together, but the important thing is your communication skill. So the thing is, all these data science, the results are going to go to the leadership. So they need to take decisions. So if you're not presenting it correctly, if you're not giving that right thought to presenting it, to projecting it, then you will not be able to sell that to them, right? So the communication is equally important too. So these are some of the things, and the statistics is one important knowledge. And programming, you can use, if you are really doing machine learning, I think typically we use R or Python or so many other, Java also can be used. And database knowledge is important, statistics knowledge is important. And from a career standpoint, there are multiple levels of careers in data science. So for example, so data can be today, I think all these things are connected. So I think you cannot say that I can only talk about cloud, or I can only talk about big data, or I can only talk about data science. All these are connected, or I can only talk about IoT, right? So if you let's start with a software engineer, right? So a software engineer, now today he needs to also look at how he can understand, gather the data from different sources. So probably today with Internet of Things, anything can talk to anything. So the data is abundant. So when you have so much data coming from different sources, you should be in a position to get the data, interface them, integrate them, make sure that all this data is connected, integrated. So you should be good in having those technological skills, which can be like you need to be in a position to understand REST protocol, you need to write in a position to write APIs. So all those are important things for you to become a mature software engineer in the current world, right? Similarly, the next role is you can also look at becoming a data integration person, in the sense like you can definitely think like when you have so many data coming from different sources, sometimes no data as is cannot be useful. So you need to apply some transformation, some massaging, some cleaning. So there are so many tools which can help you in doing that. So building knowledge in these tools, some of them are called as ETL tools, extract, transform, and load. So I think you becoming an integration engineer who can also massage this data and make it probably streamline and create that uniformity within that data. That is another skill, another career opportunity for you guys. Similarly, if you look at the other important thing is slowly when you take this to one more level up, the data science, right? Before even getting on to the data science, after your integration, the next thing is data cleansing, as I mentioned. So again, there are a lot of tools to do all this data patch, avoiding the noise, filling for the gaps. All that is an area where you can master. There are tools for doing that. So that is another career choice and prospect. Similarly, taking that to one more level, we can have ML engineers, right? So machine learning engineers. So machine learning engineers will have knowledge on the statistics and some of the mathematical statistical models. And they should be able to take this cleansed data, they should be able to fit the data in some of these models. And that is your machine learning engineer. And typically, when you really take that machine learning also into next level, right? So if you're really understanding, or if you're trying to tweak these models, creating new models, or working on some of the complex problems, be it scientific research and all that, and putting all your data science insights, right? Sorry, all your deep learning and those kind of complex algorithms. So that is the person who will be more called as a data scientist, right? So I think these are the various areas. So the thing is, the opportunity is there in all of them. And similarly, the business knowledge also plays a role, whatever the domain you are in. So try to pick one area. If you are into banking, focus on that area such that you'll be able to create value, because knowing the business or domain is also a key thing for you to get there. Okay. So I'll not be going into all these because all these are how the ML works is one thing. Training data, training the ML algorithm, and you'll be testing with the new data. And if the prediction is correct or not, based on that, either it will go back or it will continue to improve. The algorithm will be continuously improved in cycle model. And so this is what is your supervised learning, right? So you are giving a data, right? Computer vision. So this can be, you can give it as, if you label it, that's a supervised learning. If you don't label and if you just give the images, that's a unsupervised learning. So if you are giving this set of images and if you want to test, it should be able to, if it is an unsupervised learning, it should group or it should cluster with the cars. And if it is a supervised learning, it should say this is a car, right? So I think it depends on the way you are looking at it. But you need to program that, you need to tell that what is car and what is not a car. So that way, it will be easy for the model to detect. This is also an interesting thing. Known data, known responses, you will derive at the model and use this model and feed the new data. Then you will get the predicted response. That's what is your this one. So I think I'll probably don't go much. Basic use cases, I think we already discussed about all these things. Natural language processing is one important thing. People are talking about even, right? Categorizing novels, reading novels and categorize whether it is a fiction, science, whatever, right? So I think that's the level of advancement we're going to see. And education, law is also another important thing, because right, typically in the law, if you really want to solve the problem, it takes lots of time. Sometimes these cases go years and years, and so many arguments, so many data points. So if you really can use this data science, and if you can really derive intelligence from whatever the history of these cases, I think we'll be able to predict with all the details, and then we can just get these cases resolved quickly. That's one interesting use case we can think through. And health and transport, agriculture. I think there is so much going on in the agriculture on this, because we are talking about drones. The drones are doing precision farming, in the sense like it is having a lot of data which can tell based on the weather conditions, based on the nature of the surroundings, based on the nature of the leaves and so many other characters. It can tell which kind of, because typically today what we'll do is we'll spray the chemicals or we'll spray the fertilizers in a uniform way. That way, sometimes what happens is it may spoil the crop also. But these kind of things can help in terms of telling precision farming, in the sense where exactly this particular fertilizer is needed, or where exactly this the plant needs support of having a chemical. So that way, I think you don't need to. You can reduce the cost is one thing. You can also negate the effect of the health-wise issues to the environment and all that, right? So this is another use case which you can think through. We are also talking about vertical farming, because we are slowly getting on to hunger issue, and people are talking that by 2050 people will be getting onto this issue. And how is that? So our land is limited. So how we need to probably produce more? So I think people are looking at vertical farming in stacks. So, and when you're doing that, what is that? You need again data points, because when you are doing it naturally, a lot of things will play for you, in the sense your weather, your rains, your sunlight. But when you are doing it in-house, in a stacked environment, you need to simulate all that. When you need to simulate all that, you need to understand from what is there already, and then you need to simulate that. For that, you need a data point. So data science is required here too. So like that, even maximizing the yield, current output, industrial application. So I think there are multiple such scenarios. So guys, what I want to say to you guys is a field which you all need to focus You all need to give your attention to it, and you all need to learn whatever is happening there, such that you will not feel relevant. You will not feel irrelevant, right? So you'll be more relevant. And I think you all know, you might all be knowing the saying, right? Fortune always favors prepared minds. And I assume you guys are all going to be prepared, and you will always take this opportunity with both the hands, and you will get that success, and you will get that credit to your college too. So with that, I would like to take this opportunity again to thank the college management and ICT Academy for giving me this opportunity. And sorry, Dilip, I took a little more from your slot, but good luck for your next session. Thank you.
Thank you very much, sir. Requesting you, please stop your presentation so we can see you again. Okay. Thank you very much, sir, for your informative session on data science and its applications. Thank you for your time and knowledge. Irfan, sir, back to you. Please introduce our...
Yes, sir. Yes. Sir, first of all, I just want to thank sir again for covering such a vast topic in simple and understandable way, sir. I hope everything will go very well. Moving on to our next speaker, sir. Let me call upon our next speaker, Mr. Dilip Muralidharan, sir. Am I audible, sir?
Hello. Good afternoon. Am I audible?
Sir. Very good afternoon. Yes, sir. Very audible, sir. And quickly onto his profile, he started his career in IT industry more than 15 years ago, sir. He has worked in support-based profiles for the first half of his career, and later he moved on to the education and consultant. He has worked for companies such as Convergers, Computer Associate, Dell EMC, JDA Software, and now currently employed as senior technical instructor with a company called Splunk. Moreover, Splunk provides one of the world's leading big data analytics software-based solution and innovates in the area of machine learning and artificial intelligence. And his primary area of interest are data analytics and machine learning. He has vast amount of experience working on recovery solution, high availability clusters, enterprise content management. Outside of his work commitments, Dilip sir has an active lifestyle and ride his retrofitted KTM motorcycle across the country. Let's hear from Mr. Dilip Muralidharan, sir. Over to you, sir.
Thank you, Irfan. Good afternoon, everyone. My name is Dilip. I am a senior instructor with Splunk Education. Is my presentation button enabled now? Yeah, I think it is. All right. Give me one moment here. Let me enable. All right. So let's quickly talk about where I come from and why it is relevant to talk about data science and its applications. But before doing that, let me take a moment to thank ICT Academy for putting the session together. Let me also thank the college administration, specifically the staff and the teaching and non-teaching staff and the management for putting together this session. So let me quickly talk about where I come from, what my history is, and then we'll move on to the agenda. I have about 17 plus years of experience working in the IT industry. 12 of those have been in education and consulting. Before I moved to education and consulting, I used to work for support. Worked on a bunch of different things. I've worked on enterprise software. I've done GPS-based fleet management. Before Google Maps or before GPS became an everyday buzzword way back in 2000 to 2003. I've done enterprise content management with Dell EMC, Documentum, Captiva, you name it. Supply chain management with JDA Software, now called Blue Yonder. And of course, I moved to Splunk for about 4 years ago, almost 4 years ago. And ever since, I've been working on the data science platform, specifically big data analytics, from the perspective of an SIEM and an SOAR platform, right? So I primarily work on data science and automation, AI and ML solutions. On a given day, I'm usually teaching a class or I'm consulting with a customer to implement Splunk for their environment. So what is today's agenda? We're going to talk about what data science is. We're going to talk about use cases. We're going to talk about the job opportunities available in tech. And we're going to see a bunch of demos. Well, actually, we're not going to see a bunch of demos. We're going to see two different demos here. So I'm going to quickly skim through a bunch of things, since the previous speaker, Sharath, has done a fantastic job talking about data science, big data analytics, machine learning, and whatnot. And I'll keep my presentation real short. And what I'll do is I'll try to show you a demo with two different use cases, so that you can actually get to see, how, when it comes to data science, how big data analytics actually helps a business, right? So that's what I intend to do today. So let's talk about data science, right? So when we're talking about data science, we need to talk about big data, because without discussing big data, discussing data science is kind of irrelevant, right? So what is big data? Big data is usually nothing but very large voluminous data. Okay, so if you're talking about very large voluminous data, we've handled very large voluminous data in the past, right? We've handled very large voluminous data using, RDBMS databases. We've handled very large data using some sort of, structured or a non-structured file-based database, or an object-level database in the past, or even a NoSQL database of late. Right? So is that what big data is? Like really large volumes of data? Not necessarily, but one of the qualities of big data is that we're dealing with extremely large volumes of data. We're dealing with probably terabytes, hundreds of gigabytes, or even petabytes of data, right? Just to give you a bit of a context, I'm sure many of you would have taken flights to overseas locations, and I'm not sure if you've had the opportunity to, fly on Emirates. If you fly on Emirates, Emirates operates the largest fleet of Airbus A360 planes. And I fly Emirates almost a couple of times every year, because I have to go to the headquarters of Splunk in San Francisco in the Bay Area, and we have a summit, and I teach classes there, and a bunch of other things happen at work. And it always happens to be the case that the flight between Dubai and San Francisco is always an A360, because it's a high volume route. So the A360 is what customers generally prefer, and that's what Emirates generally prefers and flies between this route. Now, the reason why I'm talking about the A360 is because Airbus is actually a huge Splunk customer, and Airbus actually Splunks all of the data that is generated by the A360. And if you want to know what is the kind of data that's generated by A360, you have to understand there are about 200,000 sensors in an A360 airplane. And it produces, on average, about 4 terabytes of data when it flies on a weekly basis. That's the amount of data that's generated, right? So if you want to handle this kind of unstructured or structured data, you need to basically deal with some kind of a big data analytics software. And Splunk is, one of the several options available out there, right? Now, your big data can be structured or it could be unstructured. So structured data is basically any data that has a schema associated with it. So what is a schema? A schema basically tells you what is going to be the form factor of this particular data, right? So if you take, for example, a database, a relational database application, like for example, if you take, let's say you take a SQL server, Microsoft SQL Server, or you take, Oracle, right? In Oracle, you have a table space, and then in the table space, you basically have, your individual tables, you have rows and columns of data. Same thing in SQL, you have your databases, and then you've got your individual tables, and those tables contain different columns for different fields, and you've got rows and rows of data that fill those tables, right? Unstructured data is data that doesn't have a definitive schema that's associated with it. So classic example is this PowerPoint slide that is in front of you, right? So there's no specific schema associated with PowerPoint. You can literally put any content in there, right? In any different format. It can contain text, it can contain images, it can contain video. It could contain, other Web 2.0 objects as well, if you want to, right? So usually big data is business data because, why else would this be relevant, right? There is some business operation that needs to be managed or that needs to be helped with big data. And the most important aspect of big data is the complexity of the information, right? So these are all the characteristics that basically comprise of the big data solution, right? So when we're talking about big data, we're basically talking about these things. So when it comes to data science is a big field. In fact, I would think that data science is a very, very broad terminology that encompasses a lot of things. It encompasses big data analytics, it encompasses artificial intelligence, machine learning, deep learning, neural networks, whatever, right? So what I am going to do is I'm going to simply focus on one thing, the most important and significant aspect of big data, which is big data analytics, right? So we're going to talk about big data analytics, and we'll try and understand in the field of data science how big data analytics assists any business, and it helps increase revenue and increase the efficiency of the operations here, right? So when we're talking about data science, when we're talking about big data specifically, we're talking about correlations, right? So we correlate a lot of similar information to understand the data better. We do pattern analysis. We analyze what kind of pattern the data follows so that we can identify a specific pattern, a rigorous pattern that we can exploit to understand or to manipulate the data to our advantage. And of course, the most important use case here is prediction, right? We try and predict what kind of events are going to happen in the near future. That's a very important use case for big data analytics, right? And of course, compliance is another aspect here, right? There's a lot of regulatory requirements for any business. Some businesses have internal regulatory requirements. Some businesses have external regulatory requirements, right? Some businesses have government regulatory requirements. Classic example being pharmaceutical companies, right? Think about this, right? We are now under an active pandemic, and we are talking about a vaccine, and that vaccine is taking a lot of time for us to actually bring forward a vaccine, right? Why is it taking so much time to develop a vaccine? It's not like, scientists are not knowledgeable. Of course they are. But, that the reason why it takes so much of time for us to come up with a vaccine at this point in time is simply because of the fact that there are plenty of internal, external, and state enforced regulatory requirements in the pharmaceutical industry. I should know better because I actually worked on several customer deployments, and several training projects involving the pharmaceutical company, involving the pharmaceutical industry. In fact, I worked for about 3 years for one of India's, well, actually not one of India's, the largest pharmaceutical company in India, Ranbaxy at that point in time, which is now Sun Pharmaceuticals, right? Trained over 20,000 people over a period of 3 years to use our compliance management software at Dell EMC back in the days. So there's a lot of compliance requirements, right, that can be helped with data science. So we'll talk about that in a little bit more detail. But what are the use cases for data science? Well, automation is a big use case, right? Security is another use case. Prediction is another use case. Business process is another use case. Now, again, what I've done here is I've very broadly categorized the use cases for data science, right? These aren't the only use cases, but this is pretty much the majority of the use case out there, right? So automation is a huge use case. I mean, think about this for a moment, right? You go to a website like Amazon.in, you buy something, right? You use your credit card or your bank account, or you use some app like Beam UPI, Google Pay, something like that, and you pay whatever you've purchased for, or maybe you use, cash on delivery and you purchase something. Once you purchase that particular item, then what happens is that, automatically you get an email saying your order was confirmed, so and so and so, and this is your order ID, and this is how long it's going to take to deliver your products, and so on and so forth. How does that happen, right? I mean, nobody is sitting, in front of a computer and manually sending you that particular email. All of this is happening because there is automation that is put in place by a company like Amazon. I mean, coincidentally, Amazon and Splunk actually happen to be partners in business, and Amazon is also one of the biggest consumers for Splunk. And at Amazon, what they do is they basically use, big data analytics software to automate a lot of business process, right? So security is another huge use, it's another huge use case. Think about this for a moment, right? Not very long ago, 15 years ago, right? If you were to find a host machine infected with some kind of a malware in a big company, you would have to go ahead and investigate for malware on pretty much all the nodes, all the host machines that are available in the company, to be sure that you haven't, infected any other computer on the network. In fact, in today's corporate environment, most companies do not allow you to do a lot of things. For example, most companies do not allow you to have open file shares, right? And the reason for all of that is security, right? And big data has actually enabled the space of security big time. Think about this for a moment, right? You have a user who is not technically proficient. This user goes onto some random website and this user gets infected with a malware. Before this user has actually figured out that they've been infected with a malware, right? What they've managed to do is, they've managed to infect about 50 different computers on the network. And that's a problem. I mean, it's not any problem, it's a huge problem. It's a problem that can potentially bring down your business, right? Also, think about some very modern day problems that we've been seeing in the recent past, right? A classic example is this problem with ransomware, wherein a hacker takes control of your IT environment and encrypts one of your machines, one of your disks, and essentially what this individual does is this individual encrypts and locks you out of your own system, and you have to pay some amount of money, usually via some kind of Bitcoin, right? In order for this particular, in order for this encrypted drive to be decrypted, for that person to provide you with the decryption key, right? So that's basically what has been happening in the recent past. Now, big data comes into play in the security space because big data is able to automate a bunch of things for you. At the moment you detect a vulnerability on a particular endpoint, you can actually go ahead and block that particular machine and isolate it from the network immediately, real time, and you can raise a support ticket with the IT support team, and somebody can go and take a look at that particular machine for you. Right? Prediction is another important field where big data analytics or data science plays a huge role here. Right? So take, for example, again, going back to the Amazon example, you go to Amazon, or you go to Flipkart, or you go to Snapdeal, or you go to the Paytm mall, anything, right? So any of these given websites, if you go, you will find that you'll actually find that the website suggests what kind of products you might actually like, right? So it tells you what kind of products you might potentially like, and it tells you, what you might want to buy. And I mean, funnily, a lot of these predictions are pretty accurate. You end up, you go to the website to buy one thing, and then you end up buying a bunch of other things you probably don't even need, right? So, our previous speaker, Sharath, was basically talking about retail use cases, right? Retail is also another place where prediction plays an important role. A lot of retail companies now use data science to understand product placement. Think about this, right? If you go to a supermarket today, any supermarket, doesn't matter, right? If you go to a supermarket today, something like Spencer's Daily or something like that, I don't know what kind of supermarket chains you have in the place where you live, but here in South India, we've got Spencer's Daily that's available in pretty much most of the prominent cities. And if you go to a supermarket, and when you buy all the things that you need, you put it in your shopping cart, in your basket, right? And you go to the checkout counter to see the cashier and pay for your, purchase and leave, you'll find a bunch of things in the checkout counter, right? What kind of things would you find in the checkout counter? Well, you would find candy. Why do you find candy? You find candy because most of the times parents come to the supermarket with their children, and children are fond of candy. And if they're going to see candy at the checkout counter, they're going to demand a piece of candy for themselves, right? So whether it's a piece of candy, chocolate, or some sweets, whatever it might be, right? Something that basically tempts, younger, the younger civilians, right? You'd also find other things, like you might find, medical products, like, for example, you might find cold pills, you might find pills for common fever, you might find vitamin pills, you might find contraceptives, right? These are all aptly placed in the at the checkout counter's cashier table. And nowadays, if you go to a supermarket, I think all the candies and all the medical products have been removed. And what you would actually find is, today you will find masks and sanitizers. That's what you would find, right? So why is that particular product placed in that particular space? It's simply because of the fact that there's a lot of data science that goes behind this particular decision, right? So essentially, what happens here is that over a period of time, companies have figured out, given how given how much the product volume purchase history has been analyzed using some kind of a analytic software, they understand that the behavior of customers is going to be predictable in a specific fashion, and those particular products are placed at the cash counter. Another use case for data science is business process, right? Maintaining business processes. In fact, I would think that pretty much most data science applications arise out of the necessity of implementing a particular business process, right? So the way in which those business processes are going to be implemented could be by making use of automation, or using a prediction, or using some kind of data manipulation, right? Again, classic example. I used to work for a customer back in the days, not too long ago actually, about 5-6 years ago. I used to work for a customer in Singapore. This customer is called Sembawang Corporation. And Sembawang Corporation, essentially what this Sembawang Corporation is that it's a shipping and logistics company. That's what it is, right? And this shipping and logistics company wanted to implement our content management software, right? And we used to have a machine learning add-on with that content management software. And what it used to do was it used to predict breakdowns. So whenever there was a breakdown, there was a workflow that was implemented, like a support ticket that was raised in the content management application, and somebody went out into the field to the manufacturing plant, right, or to the shipping yard or something like that, and they fixed that issue and they filed a report on what exactly was fixed, right? So essentially speaking, what we did with Sembawang Corporation was we used our machine learning add-on, and we basically predicted when things will break down next. So when we could establish when things would break down next, we would proactively go and have a service visit or a maintenance visit on that particular factory or on that particular portion of the shipping yard to ensure that that particular component did not break down, right? Now, like I said, I'm not really going to delve deep into data science and all of the different use cases and applications and things in the field of data science, because fortunately for me, the previous speaker has done a fantastic job, so I don't need to repeat anything that's already mentioned. Instead, what I'm going to do is I'm going to show you 2 different demos. I'm going to show you one demo with some online sales data, and then I'm going to show you another demo with network analysis data, right? So we're going to see some data here. We're going to see some online sales data. We're going to look at the sales of video games. So I have some data for a fictitious, video game sales company. So I'm going to look at the e-commerce portal of this company, and I'm going to look at the data that's logged in the app servers, and I'm going to slice the data in some ways for that data to make sense. I'm also going to look at the offline sales, like the real world sales of the same video games in a brick and mortar store, and try and understand what is the sales by category, by different locations, with visualizations and all sorts of things, so that this data actually makes sense to me, right? So without further delay, what I'm going to do is I'm going to go ahead and get into a test server that I've set up. Now, this test server basically uses Splunk. Why is it using Splunk? Well, I work for Splunk, so obviously it makes sense for me to set up a Splunk server to demo this, right? But mind you, this can be accomplished with any other kind of, software that is out there big data analytics software that is out there. You could use Hadoop, you could use Logarithm, you can use ArcSight, you can use IBM QRadar, you can use, Tableau from Amazon, pretty much anything, right? So what I'm going to do here is this. I'm going to go ahead and I'm going to show you a bunch of different examples here. Now, I have online sales happening real time. So whatever data you're seeing here is actually simulated real-time data, right? So what I'm going to do is I'm going to go ahead and I'm going to run some searches. Now the searches that I'm going to be running is run in a language called the search processing language, which is what Splunk uses, right? But you could go ahead, like I said before, you could go ahead and use pretty much any other thing that is out there for you to understand and for you to, implement this on pretty much any other system. So we're going to say index equals to web, and then type equals to access bind. So I'm searching for an index where I've got my sales data that is indexed. Now this sales data actually comes from web application servers. And if you notice, I have 3 web application servers. I can go to the host, right? Or I can go to the source and I can see that these are Linux web application servers. So actually these are Tomcat servers running on a Linux machine. They are running on a CentOS machine, right? So I've got 3 web application servers, www1, 2, and 3. I'm getting the access.log, from the Tomcat servers. So access.log is a standard, log that you will find in any web application server. Now, this is the log. I can look at the raw format of the log here, and this is what you'll get to see. Now, the question is, how the hell on earth am I supposed to make sense out of this log? I mean, as a technical user, as an IT administrator, maybe this log will make sense to me, right? But as an end user, this log does not make sense to me at all. It's just gibberish, gobbledygook that is present on these logs, and I actually have no idea what the heck is going on in here, right? So what I'm going to do is this, right? I'm going to try and understand what is happening with these sales over here. So this is basically where data science comes into play, right? I can go ahead and implement nothing sophisticated, right? Very, very rudimentary high school mathematics in here for me to understand what's going on. In fact, to be very specific, I can implement high school statistics for me to understand what is going on in here. So I'm going to run some stats command here, and I'm going to try and understand how sales is going to, sales is basically picking up in these particular locations, right? That's what I want to do. So how do I go ahead and how do I work with this particular piece of data here, right? Well, what I'm going to do here is I'm going to, let me think about what I want to do with this data here. This is sales data. So, okay, what if I want to see the kind of sales, or rather the amount of sales that I have had in the past 1 week? I can do that. Right now, I am looking at the data for the past 24 hours. I'll just say last week here, right? So previous week, so that I have previous week's worth of data here, right? Now, what I'm going to do is I'm going to run a simple statistical command. So the command that I'm going to be running is called as the time chart command. So I'm going to say time chart count, rather some of, I have a field called price here. So price is basically nothing but the actual price of the product that I'm selling. So I want to know the daily revenue here, right? And I'll say by product name. So when I run this, look, I've got a daily sales, right? So this is basically all the products that I've sold in the previous week. And I've got, I've made this much amount of money with these different kinds of products, right? So I'll just say limit equals to 0 because it only shows the top 10 sales here. So I'll try to show every other product that has been sold here. See that? Now, the cool thing about this is that I can also put this in a visualization. So this is a column chart that I've got. See that? That's a column chart. Now, I can also change the visualization to anything else. I can change this to, for example, a bar chart here, if I want to, right? But you know what? I'm going to stay with the column chart because I like this visualization better. So in a matter of seconds, what have I done here? Data science has helped me understand some rudimentary log that is full of some ununderstandable, undecipherable gobbledygook from a Linux server, right? Into a beautiful report that tells me what exactly is going on in here, right? So from this visualization, I can clearly see one product. What is that product? If I hover my mouse over this, it says Dream Crusher. This Dream Crusher video game, this game is selling quite a lot. It's selling, in fact, it's the highest selling, product at this point in time. Very interesting, isn't it? So I'll just go ahead and I'll save this as a report. So if I save this as a report, I can bring this forward in, in the future without having to write all these commands and write all this processing language. So I'll say total sales last week. And I'll save this report, and I can even add this to a dashboard. So I can call it sales dashboard. And I'll just say total revenue last week a day. I'll just go ahead and save this in a dashboard. So if I want to view the dashboard, I can certainly view that dashboard. So look at the dashboard here. This is the dashboard that I created. See? So all it took me is, 2.5 minutes for me to explain. I mean, if I wasn't doing the explaining, I would have done this in probably 30 seconds, right? So all it's taken me is a matter of minutes for me to totally make sense of a log that is otherwise undecipherable, but I've simply used data analytics software to understand, to decipher what exactly is going on in here, right? Now, what else can I do here? What else is decipherable here? How can I, understand what exactly is going on in here? Well, I'll tell you what, I can go ahead and I can I'll use offline sales data. I'll say index equals to sales. So what I have here is offline sales data. Actually, customers are going to like a store and they are buying video games from my company. Now, what I want to do is this. I want to know what kind of sales I had only in a particular part of the world, right? I want to understand how much of, which part of the world do we want to, okay, let's say we want to look at sales in United States, All right, that's what I want to do. I want to look at the sales in the United States in the past, week. So let me choose last 7 days here or last week, pretty much the same ballpark. So what I'm going to do is I'm going to look at the fields that will help me understand, the location of the sales. So I've got a lot of fields over here. See, vendor country, vendor ID, right? Latitude, longitude. I've got map data here. What I've also got is, vendor information, right? Vendor ID information. Now I know, because I work for, the company, I know all the vendors under 3,000 are, vendors from the United States. So I'll just go ahead and say vendor ID is lesser than 3,000. When I do that, I get data for the last week, but if I look at the vendor country, I only see United States here. So I've successfully filtered by vendor country, right? So all I need to do right now is I just need to go ahead and I just need to figure out the sales by, the different states in the country. So I'll use a chart command because it draws a chart count by I'll use the vendor state province, field here. And now that I've done that, I'll simply go ahead and use another mapping command, and I'll use a map that I've saved already in my, in my Splunk deployment. And I'll just use this vendor state province field to draw the map. Now that I've got that, look, I can go to visualization, and what I can do is I can look at a map. And when I look at this particular map here, feature, look, I've automatically got the map that I need. See that? So this is all the sales that is happening in a particular location. I can also format this map. It allows me to figure out the number of bins here. The colors can be divergent or they can be categorical as well, depending upon the numbers, right? So that's what I am getting to see. I'll go ahead and I'll save this as a report. So map of sales in USA. I'll add it to a dashboard. I'll add it to the existing dashboard here, which is my sales dashboard. And I'll say last week's sales in the USA by state. So I've added that to the dashboard, and let me look at the dashboard here. See, this dashboard now has country-wise sales information as well. See, sorry, state-wise, sales information here. That's what I get to see, right? So that's online sales data that I have been manipulating here, right? So let me go ahead and let me also try and put in another kind of sales here. So I'll use exactly the same data here. I'll use the web, the online sales data. So let me show you. All right. So now when I'm selling things online, not every sale is going to be successful. Some of the sales might fail due to some kind of errors. So what I want to do is I want to look at only the successful sales. So I'll just go to the purchase related actions here. And then I'll choose the status, because this is the web status 200, which means it's a successful HTTP request, right? And what I'm going to do is I want to know the location of the customers who are buying my products online. How do I do that? Well, I do have, I have an IP address field called client IP, which is the IP address of my clients. So I can use a mapping command, IP location, and then say client IP. And look, I'm building a simple, client IP field, which gives me the latitude and longitude fields here. So now I've got longitude, I've got latitude, all of that, see? So with this, I can easily go ahead and I can build a map, right? So say, so look at this here. Now I have got a beautiful map of sales that is happening across the world. And I'll just simply say, let me leave it at last 24 hours. I'll report last 24 worldwide sales. So I will also add this to a dashboard. I'll add this to the sales dashboard. Worldwide. And I'll go ahead and save this into the dashboard. And look, I've now got a beautiful dashboard here. So I'll edit this particular dashboard, and what I'll try to do is I'll try to bring this down. Oops, let me try to get this to the bottom here. Interesting, why can't I do that? Okay, this is better. So as you can see, I've built a very simple sales dashboard, right? So with the power of data science, I've built a simple sales dashboard. That sales dashboard tells me the revenue last week on a per product basis. And it also gives me a beautiful map of all the different categories of sales that has happened, in the past week. And there's a worldwide sales map for my online sales as well, right? That, simply put, is, data science in action. I've taken something as very complex as this, right? I've taken raw data from a server, right? Which is very difficult to be deciphered even for a technical user like a server administrator. And I've built a nice dashboard that any layman can understand what's going on. If I send this dashboard over to my manager will be able to quickly decipher what's the sales status. How exactly is sales going on in the organization, right? So that's basically demo number one. Let me show you another example here. I'm going to analyze corporate network. That's what I'm going to do next. All right. So I have some corporate network data. Again, this is also real-time data that I have, right? So I've got corporate network data, and this network data is available to me. Do I have this data? Okay, I think I have about 1 year's worth of corporate network data. I'm not going to use 1 year's worth of data. I'll just use a few days worth of data just to demonstrate, how this can work. So I will go ahead, and what I want to know is this. I want to understand the internet usage in the company. All right. So how do I want to understand the internet usage in the company? Well, I want to look at the entire network traffic, and I want to see what kind of usage, my employees are putting the corporate network to. So how about that? Let me go and let me get to my search here. Right, source type is Cisco WSA Squid. Now, Cisco WSA Squid is very common data. It's Cisco network data, right? So this company, I think, is using all Cisco products. So, which is the reason why I'm able to take Cisco data from the network here. And what I'm going to do is I'm going to do the same thing that I did with the online data. I'm going to draw a time chart, right? And then I want to look at this by usage. And look, I've got borderline use, business use, personal use, unknown use, violation use, right? So I'm going to go to visualization and I'm going to look at this in a line chart. And if I look at the line chart, I get a beautiful line chart that tells me what kind of use this business has been put through. So I'm going to save this as a report. I'll say corporate network usage. And I'll add this to a dashboard. I'll create a new dashboard. So network monitoring, and I'll call this So there you go. I've saved this as a panel in a dashboard, and you can actually see this nice little line chart available to you in the dashboard. Now, what else can I do over here? Well, I can also go ahead and I can analyze what type of content I'm using as well. How do I do that? Well, you see, I have a HTTP content type field here. So I can use a stats command to figure that out. Stats. So what I'll try and do here is, look, this is what I've got, right? So I'll change the visualization to a pie chart so that I can understand what kind of content is being used. And I'll save this as a report. So I'll save this as network usage topic content. And I'll save it and I'll add it to a dashboard. I'll add it to the existing dashboard, right? Internet and with type content. And if I go to the dashboard right now, look, I've got the internet bandwidth by content type dashboard. See? That's what I've got. Now, what else can I do here? Well, I can go ahead and I can, remember, I told you I can do pattern analysis, right? I'm going to try and do some pattern analysis here. I'm going to try and introduce some kind of an intelligence here. All right. So what do I want to do here? I want to do some intelligence work here. Let me think. Give me a few seconds here. Let me come up with a use case here. What do I want to do here? Okay, here's what I want to do. What I want to do is I want to understand how exactly my my network is being exploited. There are some hackers who are trying to hack into my corporate network, especially my application servers, right? So I want to try and understand what kind of attacks are being waged by the hackers. So how do I go ahead and do that? Pretty easy. I don't really need to do much at all. I just have to understand what kind of usage my Linux server is being subject to, and then what I would like to do is I'd like to look at the pattern. So security. I've got a security index and then source type. It's Linux secure. I don't know if the data is here. Let me see if I've got the data here. Oh, I do. Okay. Now, look, I have a field here called source IP. These are all the IP addresses, but I specifically want to search for failed passwords. So I'm going to say fail. I'm searching for failed or invalid passwords here. And, what I'm trying to do here is I'm trying to see how many times a password attempt has been failed in this Linux server. Now, I see a lot of failures. I see 9,952 failures in the past 24 hours, right? Now, unfortunately, I want to know which are genuine failures and which are, hacking attempts. So what I would like to do is I have the source IP field here. I can run a transaction to understand pattern here, right? So I can say transaction source IP. And I do this, notice I now get a transaction of my IP address, and holy cow, look, so many multiple failures here. These are all definitely some kind of a brute force attempt, for sure. So what I'm going to do right now is I'm going to go ahead and I'm going to say top values by time here. And then I'm going to get, a time of password failures. I'll try and minimize this to the last 60 minutes to see if I get data. Okay, there you go. So this is what has been happening in my corporate network, right? In the past 60 minutes, this is how much attempts have been happening in my on my corporate network. And I'll go ahead and just include all the other users here, and I'll save this as a report, and I'll say hacking attempt on Linux server, right? I'll add this to a dashboard. I'll add it to the network monitoring dashboard. All right, so I have built that dashboard here. So if I edit the dashboard, what I can actually see is I can see this. So not only how long have I been hacking at this? I've been doing this for the past 25 minutes, I think, max. I mean, if I wasn't doing the explaining as to what I was doing, I could have done this in probably 5 minutes. But, all that I've done here is, I've taken this very rudimentary complex data, and I've used the power of big data analytics to build two beautiful dashboards to show what exactly is going on in here. So even if a lay person is going to look at this particular dashboard, they're going to pretty easily understand what's going on in here, right? So this is the network monitoring dashboard. I've basically used the network data, corporate network data, to analyze the corporate network data. And this is the sales dashboard. I've used the corporate sales data for me to look at the sales here. Now, let's talk about some of the job opportunities in tech, specifically with regards to data science. So when it comes to data science, usually if you want to start off as a big data analyst, if you want to start as a data analyst, right, or some kind of a security analyst or ops analyst, these are all data science jobs. These are all, big data jobs. You can expect quality of work. There's very little coding that is done as such these days, unless and until it's a custom app. Solutions are available out of the box. So even a non-technical business user can put together things. I remember 15, 16 years ago, we used to do rote jobs. People who don't work in the tech industry used to think that we're some kind of scientists and we're cooking up some, major rocket science stuff up there. But unfortunately, what we're doing is just writing and rewriting the same report and fixing the same kind of problems all day long, which is what we used to do. But we no longer do that because all of those things are automated away. So there's a lot of focus on niche markets. So focus on the niche markets. Data science is applicable to pretty much any and every business out there. But specifically, it's a niche market wherein a particular use case is what takes precedence for a particular business, right? So like the previous speaker explained, if you want to go into the banking industry, focus on the banking industry. If you want to go into the tech industry, focus on a particular portion of the tech industry, like security ops, right? Or networking, or the business analytics, right? So mathematics is a very good skill to have, specifically statistics. High school and college statistics plays a lot of prominence. So some of the times I use an AI demo in these lectures. I decided to not do it today because we're not necessarily talking about AI as the subject matter. But when you're talking about machine learning and AI, statistics is the core component of any algorithm that you would build. So is logic and reasoning and critical thinking skills. Right? So I think I've taken about 45 to 50 minutes of your time, which I think is fair enough. So I'm going to conclude this session, and I'm going to open the session for questions. So if anybody has any questions, maybe the participants can put it on chat, or maybe someone can facilitate the Q&A session. So I think I'll be happy to answer any questions that you might have.
Yes, thank you very much, sir. Requesting you please stop your presentation.
Okay, yep, done.
Okay, Dilip sir, thank you very much for your informative and productive session. Actually, in our syllabus, there is a topic called as data science, but we are, as a faculty member, we are unable to visualize the data to students. So because of your presentation, our students are able to visualize how data science looks like.
Yeah. Rahul, I just want to add one comment here. So,
Please, sir.
it was an amazing session, really. I really learned how the Splunk is doing such a great job in terms of demonstrating those insights, right? So that's a great learning for me too. And so one other thing I just want to add is, as Dilip rightly mentioned, security is one key area, right? So today we are talking a lot about autonomous. So the thing is, all these products are, you can provision, self-provision, self-secure. So the thing is, with the help of this data, huge data available, I think we can make this security as an autonomous thing. So the enterprises can automatically make sure that all these vulnerabilities are handled seamlessly without any manual intervention. That was really a key takeaway for everybody. So thanks, Dilip, for that. Yeah.
Okay, I'm here for the vote of thanks. Okay, first speaker, Mr. Sarath sir from the Oracle. Second speaker, Dilip sir from Chennai. I'm very much thank you for their valuable time, knowledgeable session. Both sessions was very, very good. I'm also thankful for our educational partner, ICT Academy. G. Venkatesh sir, Head Academic Operations. Mr. Irfan sir, ICT Academy Relationship Manager. I'm also thankful for our principal, Dr. Murumkar sir, who is always supporting our activities. Our head of the department, Mr. Upendra Chaudhary, and all our teaching and not teaching staff. Without their help and support, this webinar won't be successful. And last, our all participants, thank you very much for participating in this webinar. Thank you all.
Thank you.